Hi everyone, my name is Miroslav Šedivý. Do we have a problem with the encoding? No, that's still wrong. Maybe if you try just to plug the cable the other way. No, still wrong. Šedivý. Great, now it works. Okay, so my name is Miroslav Šedivý, and unfortunately my name is sometimes invalid. I was born in Czechoslovakia, studied in France, living now in Germany. This is how you pronounce my name, and this is how you type it if you have the correct compose key on your keyboard. And now we are going to speak about names in Python. So how to distinguish between strings and bytes, about encoding, normalizing, case folding, sorting, regular expressions, and of course we are going to speak about names on the web. It means how the names are processed on websites, online forums. In Python 3 now, fortunately, we can distinguish absolutely clearly between strings and bytes. String is composed out of characters. Each character can be one out of about 1 million characters. So these are the characters that we write, that we understand as characters. And if you are writing the file on the disk or sending it over the network, you need to convert it into bytes, because bytes, there are always 8 bits and they offer only up to 256 combinations. So how are we going to combine or to work with these two types of information? If your name is Chuck Norris, you have no problem. You just encode your strings into bytes directly, and the other way around. There is no problem because your name is just pure ASCII. And each character corresponds to 1 byte. So you see the length of both chains is 12 characters or 12 bytes. On the other hand, if you are from Germany and your last name is Müller, then with the U you will need 2 bytes because in UTF-8, which is the default encoding in Python 3, the U is encoded using 2 bytes. Again, your string, you encode it 2 bytes and then decode it the other way around from bytes to strings. If it is a Chinese, this is no last name, this is word ni hao, so hello in Chinese, and in this case 2 Chinese characters will be encoded into 6 bytes. Default encoding in Python is UTF-8, but there are plenty of other encodings that are older than that, and that are able to contain other information. So for example, ASCII, as we saw before, in the case of Chuck Norris, there is absolutely no problem, and it is also the case of most names in the USA. On the other hand, Müller, you cannot encode it using ASCII because the U is not contained within ASCII. In that case, you are using something like Latin 1, where the U will be encoded using 1 byte. My last name, Šedivý, this comes from Czechoslovakia. It means gray-haired. You see, we in Central Europe, so languages like Czech, Slovak, Polish, Hungarian, we used Latin 2, where this is almost the equivalent of Latin 1, but just a few characters that are in Western European languages are not in Central European languages, so we have replaced them by other characters, and in this case, Šedivý can be stored exactly using 6 bytes. But sometimes this doesn't work very well because, for example, here in Germany, when I get packages from one big online store, they write my last name like this. So instead of the sh, a single character, there is a question mark. Why is it like that? If you take my last name and you encode it using Latin 2, you will get 6 bytes correctly. If you encode it using Latin 1, which is very probably used by this company here in Germany, it will raise an exception, Unicode error, encoding error, because the sh character is not contained in the Latin 1 character set. But there is a possibility to tell, okay, do anything, do it somehow, and if there is a problem, just replace the missing or the unknown character, replace it by a question mark. Python has default behavior is to replace it by a question mark, with a question mark. You can, using codecs, you can define another replacement. So, for example, in this case, if you tell replace, I define a method called replace randomly. This will replace the characters, for example, by a function. So it is possible to encode into Latin 1 or Latin 2, which don't support all characters, and the invalid or unknown characters will be replaced by something that you define. And there are some other companies here in Germany that just enjoy sending me emails or posts or mail and using always different encodings. So, for example, this is one company that where I have an online account with my last name written correctly, and every time they send me an email or print a customer card or something like that, they just screw it up a different way. So you see that usually it is always better to encode everything using UTF-8, and then you have no problems. Other case, this is a big flight airplane company in Germany where I wanted to buy a ticket, and they told me you can only enter letters in the adult's last name field. Sorry, my name consists only out of letters. Sh or long Y is a letter. So what is a letter? Letter is in Python 3 you can just use everything that looks like a letter to call variables. So you can do something like this. And if you want to know what is actually a letter, you can use Unicode data from the standard library. And in this case, we can see which character, how is it called, to which category it belongs, and what is its name. So, for example, for these few A's and sharp S's, which is sharp S in German, corresponds to 2S in some grammar cases, sh and dot and smiley, you see that in the first column, the character, in the second column, you see two characters, something like LL, LU, which means it is a letter. LL means lowercase letter, LU means uppercase letter. And then comes the name. And then you see that everything that is defined as a letter can be used within variable name. So you cannot use smiley as a variable name, but you can use all European, Asian, African languages that are defined within Unicode and that are defined as letters. So this is the list of all categories. And even if you open application like character map, it will show you what the name of the character, the number of the Unicode character, and the category. Everything is contained within there. Case folding. This is converting between uppercase and lowercase. Is simple in Python, but sometimes it's wrong. You just with dot upper or with dot lower, you convert between uppercase and lowercase. It works for most characters. It doesn't work for all characters. So, for example, the sharp S in German, is a character that if you uppercase it, you will get two SS uppercase, which is wrong because in German, since 4 years, there is a form of uppercase sharp SS, which is a little bit wider. This is it. So if you take this uppercase sharp SS and you lower it, then you will get it. So this is not a symmetrical operation. And there is something different, there is something else that is even in the basic ASCII, which concerns American English as well, and which we did wrong. This is the letter I. If you take lowercase I, you uppercase it, then you will get two different characters, because lowercase I and uppercase I are different actually. In the logic of most European languages is the same, it's equivalent. But there is one European language that does it differently and where our logic breaks it for them. And that's Turkish. Because there is I with dot, which is I, and I without dot, which is Ö. So they have to do it a little bit more complicated. They have to import international components for Unicode library that does the converting between those two I's, dot less, uppercase, lowercase, and I with dot uppercase, lowercase for them. Normalizing. Even if you take you read some bytes, you convert them to strings in Python as soon as possible, which you should do, and you should convert from string to bytes as late as possible. Even if you use the strings the whole time, they can be different. Let's take a German word süß, which means sweet. That contains 2 characters outside of ASCII, because they have some diacritics on them, and you normalize them, which will give you 2 different words. The first one contains 3 letters S, U, and scharfe S. The second one has 1 character more because it normalized the U into U and combining the erases. And you see that these are 4 characters, but the word is always 3 characters long. And not wrong on my slides, in the second word, the entry with the combining the erases, because the 2 dots are have no width. That's why the whole column has just moved by 1 character to the left. And this way you can combine more characters together. The scharfe S won't be decomposed. It's a basic character. And using this, you can actually do something like ASCII's words or letters that are written using special characters. An example that you can do with this is a very popular answer from Stack Overflow to the question how to parse XML using regular expressions. You can do that. And you see at the end the plenty of these special characters means that were made using normal character and then adding any number of combining diareses and combining other characters from this category. Sorting, alphabetic. So you have something like phone book, list of speakers at a conference. How do you sort them? If you just take all the characters and you use the standard sorting function of Python, you will get something that is sort, but that is not sort according to natural language. Because you see, in this case, we have uppercase AOU, then lowercase AOU, and then we have some AOU with the erases, and then lowercase sharp s, and then comes other characters. So this is sorted according to the Unicode value or code point, which does not work for most languages. If you have to define a locale. So, for example, if you define the German locale and you sort the characters, you will see that the uppercase, lowercase letters will be together, and the A, the erases or umlaut, will come directly after A. This is the German alphabet. The Swedish alphabet also has this character A with the erases, but it put it on at the end of the alphabet. So depending on the locale you are using, you will get a different order. In Czech and Slovak, we have other list of other alphabetic list. So, for example, in Hungarian, the CS, which is sound ch, like the last word cheapish, which means sharp, that CS is a standalone character or letter containing. It's a letter consisting of 2 characters that has its place between C and D, and that's why cheapish comes after zwykli. In Czech and Slovak, we have all these ch, so the letters with karen. We put them directly after the letters without karen, and we have something like CH, which is the sound h, which comes between H and I. In French, it is even more complicated. They sort alphabetically according to the letters from the left to the right. But if you have accents in the word, you sort them from the right side, from the right to left. So first come 2 words kot and kot, which have no accent aigu on the I, and then come the other 2, and then between these 2 words you sort whether there is an accent circumflex on the O or not. So this is the French way. And you would have to define a new locale or call a new locale, set a new locale for every language you are using. The problem is that locale is connected to the process. It means that if you have a library in some web server and you show to each user their alphabetically sorted list of names or something, then each time this function is called, it would change the locale of the whole process. You don't want to do that. Import ICU, which is Internet Code of Unicode, and create an instance, which is then an object, and then you can sort letters or words according to some locale, but it will not affect the locale of the process. Or by UCA, which is simpler, but it doesn't define a language. It only has some natural list of characters or letters that are okay for most international lists, but which don't respect exactly the German, Swedish, or Slovak or Hungarian way of writing things. Regular expressions. So if you have a problem, use regular expressions, then you have two problems. Let's say that we have this word München, which is the German way for Munich, and the number 1 to 3, and we want to extract the word München. It is a group of letters. How to do that? You can extract all the characters A to Z, but then it will extract the letter M and then the rest can, so it will ignore the U with the erases, and it will ignore the 1 to 3. No, we don't want that. You can ask for all alphanumeric characters, \W plus, it will extract München correctly, but it will return also the number 1 to 3. No. Then you can use the third-party library regex, which works exactly like the standard libraries RE, and then define with the \P, define the category of the character, which is uppercase L, which means a letter, any letter, uppercase or lowercase, and then it will work exactly as you wish. So, I came here for Python, but I stayed for names. I would like to ask you, who of you can write their complete name within this form? First name, last name. Anyone has a middle name? Do you have something like metronymic name, like in Swedish, Adriana Lopez Gonzalez? Or do you have last name, first name, inverted, like in Hungarian or some Eastern European languages? Are there any popes or queens or kings here? Do you have something like in Icelandic, the name of the father that comes after your first name? So, for example, someone who is Sigur and his father was Johan, her name is Sigur Johansson, and you don't call them Mr. Johansson, you call them Sigur or Mr. Sigur Johansson, and in the alphabetic list they are not under J, like Johansson, they are under S. So, there are plenty of different ways how to write a name. So, for example, someone has only a name. And there are plenty of all these fonts, de la, deli, so all these aristocratic titles that are part of the names. And doctors and PhDs, which become part of your name after you finish your studies. What you should do, use just one form for the whole name, any way the person writes it, and then something like, how should we call you? So, for example, in my case, full name is Miroslav Šedivý, and how should we call you? You can call me Miro. Because there are people who don't fit into all these forms. So, for example, Mr. T is first name Mr., middle name period, last name T. And if you check for what the user writes in, I write my name and the German form tells me, please enter characters from the European character set only. Sorry, Czech and Slovak is European language. Please enter a full valid name. My name is full and my name is valid. The names of the people cannot be invalid. Don't assume anything. So don't put any random limit on the length of the names. So there are people who have really long names, short names. Don't use stop words. If it is a stop word in English, it can be a perfectly legal name in other language. The family members don't have always the same name, family name. So, for example, all male members of my family are Šedivý, gray-haired, and the females are Šedivá, gray-haired, but which is grammatically only the female form of the name. there are different transcriptions of from non-Latin alphabets. So, for example, Cyrillic or Chinese characters, they just, in every language, they just transcribe a little bit differently. Or it works also the other way around. So, for example, I went to Russia twice, and with my passport, they put a visa with the Cyrillic form of my name, and on both visas, the form was a little bit different because it was the Russian transcription of my last name from Czech or Slovak. Don't put something like maiden name or ne for the names before wedding, before marriage, because there are also men who change their last names or family names. One letter name is probably not an initial. So, for example, Benoit Bemel, the B is not an abbreviation of anything, and probably or printable characters are fine. If you have a problem with, if your last name is null and the form has a problem with your name, then please see me after my talk. That's wrong. You should not. You should accept actually if someone's name is null, because NULL are just 4 letters. Then we know the system of databases, which is SQL injections. Of course, you shouldn't have problems with that if you write an app. The names of the streets and cities, the same. This is the most popular name of a street in Germany. Einbahnstraße actually is not the name of the street. It means a one-way street, but it looks like a name of the street. And what you can see probably in the USA are the names of German cities or German streets that are called Hauptstraße instead of Hauptstraße, because the OCR are probably interpreting the sharp S or the sharp S as B, because it looks the same, although it's a different character. The names of the cities, they can be really short, or that's somewhere in Scandinavia, Y, that's in France. And if you, in your form, you ask something like, what is the name of the place where you were born, at least 6 characters. Sorry, no, there are places like that that are much shorter. On the other hand, you have names like Llanfairpwll, Gwyngyll, Gogerach, Winthrop, Pantasilio, Gogogoch in Wales. And places like Chrzęcierzewoszyce, Powiat Wękołody in Poland. Or there even sometimes you don't need an address at all, because you just write where you want your mail to be sent, and in Iceland it works like that. There are plenty of lists of falsehoods that programmers believe about names. I just invite you to read it and to check whether your app can deal with that. So, is your name invalid? No, the names of the people cannot be invalid. Please respect the names of your users. Don't break the locales. So import ICU, for example, for sorting. Convert from bytes to strings as soon as possible, and then from strings to bytes as late as possible. UTF-8 is cool, Python 3 is cool too. Please use Python 3 and UTF-8. If you tell your user that their name is invalid, you will land on the Twitter account, your name is valid. Yeah, it's called your name is valid because your name is invalid is too long for Twitter. Again, we have a limit on the length. And please be nice. Thank you very much.